let's look at many-to-many. Our UML class diagram had an example of this, where we have an association between a student and a section, where one student might be associated to multiple sections, and the sections can have many students enroll in that section. Right? And some meta information about the relationship is being captured in an association class called enrollment, such as what grade did you get when you were enrolled in this particular section? What grade did you get, right? Or any other statistical information about that particular relationship between the student and section. Okay. If there were no meta information about the enrollment, it would be perfectly fine to just have student to section, many to many. The class diagram has no problem of having many on one side and many on the other. Nevertheless, when you're going to implement it as in a relational database, there's no physical way of implementing many to many, and you have to reify it. You have to convert it and add an additional table, right, to establish the relationship between the two that has references to the original classes. If it's a many-to-many, just like this, with no meta information, we reify it with what we refer to as a mapping table. It's a table that just maps records on one table with records in another table, and that's all we call it. That's all we refer to it. If instead we have an association like this, we are explicitly saying that we want to capture some information about that association. Not only do we have to capture the foreign keys to both the student and the section, we also have additional fields that we're capturing meta information about the relationship. Okay, so such as the grade you got in that association. So the two names for the same thing, almost the same thing, right? We have an additional table that has references to the other table, to the other two tables, but if that's all it has, we call it a mapping table. If it has not only those two foreign keys, but additional meta fields describing that type of relationship, then we call it an association table. Okay, it's just some semantics. In this case, it is an association table. Right? It's not just a mapping table; it's an association table to implement an association class. Anyway, so this can be implemented. This can be implemented by using JPA support for a join table. Right? A join table is, as the name suggests, it's going to have foreign keys to the two records in question. Right? In this particular case, we are associating a section table that we're about to create associated with an existing user table. Right? And we are associated using this join table called enrollment. Okay. Now this join table, notice that it's listed as it's mapped. It's configuring this brand new field called enrolled sections. So from the student's point of view, I want to know what sections I'm enrolled in. From a section's point of view, I want to see what students are enrolled in this section, and obviously they don't have to be the same, right? There has to be some overlap, obviously. If I'm enrolled in this section, then the section should know that I'm enrolled in that section. So there's an overlap from looking at it from both places, but the section will have any number of students, but each student will look at it as any number of sections, right, from the student's point of view. So anyway, so let's implement the section first. Let's see, we'll add a new model here, and we'll call it section. It'll be an entity. So entity list ID. Excellent. Student. We don't have student. We didn't create student. Did we do inheritance? I thought we did inheritance. So we must have not done inheritance. We must have skipped it. Okay, so let's create a student class. So model we had user and faculty. Okay, we didn't do student. Okay, we'll do student now. So we'll do new class student, and the student is an entity, and extends user. We don't need to reestablish the primary key, IDs and whatnot, right? That's inherited from user. We don't have to do that. But we do have to provide the fields that are specific to students. So for students, we'll say that we'll have an integer graduating year. We'll have a Boolean has a grant. Okay? And let's provide also the setters and getters that go along with this. All right, so we have a user. Very good. Let's go back to the section. The section wants to know the student, so now it knows who it is, the student. There we go. What else do we need? Notice that we've established the sections that have IDs, unique identifiers. It has titles, so the name of the section, and it's going to keep track. Each section will know which students are enrolled in that section, right? So that's a very common use case. You know, want to look at, you select a section, the section should be able to tell you which students are enrolled in that section. Or from the student's point of view, you'd like to be able to say, well, select a student, it'll tell me what sections that student is enrolled in. So they point to two different things. Obviously, they overlap. Okay, so we'll need setters and getters for the section. So let's do that. Section, setters and getters. Oops. We'll add it here. Why does that? Oh, right. We have this. Can I? Replace all? Okay. There we go. And let's add setters and getters at the end. Excellent. There we go. We have the setters and getters. And presumably on the other side, the student will have a list of sections. All right, so let's do that. Let's go to the student side and add, oops. From the student side, we'll add right here, enrolled sections. So each student will know what sections they are enrolled in. Oops. There we go. So let's take a look at this. So this is the property, right? So each student will know what sections they're enrolled in, and the way we're going to keep track of students knowing which sections or sections knowing which students is that we're going to have a new brand new enrollment table. We're going to have two foreign keys, right, which are going to point to the student and is going to point to the section, and they're going to be foreign keys that reference the ID fields of each one of those tables. Okay. All right. Excellent. Let's see. Anything else? Let's refresh. Let's restart this. Let's recompile. Let's see if it generated our brand new table. It didn't. Why did you not generate my table? Let's see. Should I run this? Another way of doing it is running the application will generate it. Run. Maybe. Taking a while. today, maybe? Jeez. It's taking its time. There it is. There's my enrollment table. Okay, and we can take a look at what it generated for us. Let's see. And there it is, right? So we have a student ID, we have section ID. It created a constraint of a foreign key that references the user ID, and it didn't generate the other one. Wait, what? Did I miss something? Oh, it failed here. It says command blah 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 error executing DDL via JDBC statement. So let's see. It created the enrollment table for student ID and section ID. It added graduation year to the user, the grant has grant. It added the foreign key here, but it command acceptance exception blah 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 blah. Executing generate. So I think it was successful at doing the first alter, but it failed during the second alter. Cannot add foreign key constraint. Why? Hibernate. Add enrollment. Key. Okay, so I tried to add this foreign key constraint. Do an edit, find. Okay, so that constraint was added. Why did it not add the other one? This was the other constraint, right? Okay. Sometimes it'll fail because perhaps these keys need to, these constraints names have to be unique, and the constraint name might be already in use, and it'll fail. I'm going to add it myself. I'll add it myself. So let's see, we can do enrollment, we can do an alter, and we have, let's see, foreign keys. We have this one over here that references the student ID, and we'll add a new one here. So this is the student, so this is a section foreign key, which references the section and the section ID. Apply. Apply. Oop. Cannot add foreign key. Alternate section ID. Do I not have? Does the section not have an ID? Maybe that's what it is, right? Let's see. Let's look at the section. What do we have for the section? Send. Well, it does have an ID. It does have an ID. Let's see. What is it that don't you like? Section, foreign key, triggers, partition, student ID, skip, and this one points to what? This one points to student ID, and this one points to section ID. Alter table, blah, 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 enrollment, at index, section ID, ascending, alter table, blah, 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 enrollment, add constraint, foreign key, blah, 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 blah. References, jp.section ID, on delete, no action, on delete. And what don't you like about it? Error, duplicate key. Duplicate key name, blah, blah, blah. Okay, well, let's change that. Apply. Alter cannot ever single 7 execute an error on a duplicate key. Wait, I just IDX. Do you see it anywhere else? Let's try it out over here. Let's see, is there anything wrong here? Section ID, ascending, blah, 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 enrollment. Add constraint, add index. This has to be unique. Section ID, add index. Execute. No, it doesn't like it. Cannot add foreign key constraint. Well, I'll need to debug this. Why this is not working. All right, let's continue. All right, so it should create this foreign key constraint for the sections and the students. And once we have those, we create a repository for the section, and we do basically the same thing we did earlier for the faculty and the courses. Right? If we want to establish a relationship between the courses and the faculty, we need to first retrieve the individual faculty, the individual section, the individual student, right? And then establish the two-way relationship. So here's an example of creating two sections, section 1 and section 2, retrieving all the sections. And we know how to do that. Let's look at enrollment. Now the enrollment is, we're going to have the same challenge that we had when we established the relationship between the faculty and the course. Right? The same thing that we had to do, the two-way relationship between the two. Same thing here. We would implement the enrollments from the section's point of view. We need to have, if we enroll a student in a section. Right, so here, right, if we enroll a student in a section, we're going to have to tell the student that, hey, you are enrolled here, right? So just so you know, right? So on the student side, we have to go the other way around, right? We have to say, hey, student, you need to make sure that you know that you are enrolled here. Okay, so if we go to student, and these are the enrolled sections, we need to be able to go the other way around and say, get the enrolled students. Okay. Enrolled sections, I think we'll need to add these. I don't think we have the setters and getters for this. And we'll add it at the end. Yeah, there we go, set enrolled. So now sections, there we go. So if we can enroll it either way, right? We can either tell the section the student is enrolled, or from the student we can say, hey, you are enrolled in this section. Either way should work. And from either side that you start, we have to not only update our list of objects that are associated with us, but we also have to go the other way around and tell the other relationship that says, hey, did you know that you're enrolled in this section? If not, then we need to tell the student, hey, well, students, add me to the enrolled sections, and the other way around, right? From the student's point of view. From a student's point of view, we have to, if a student is enrolling in a section, we need to ask the section in question, hey, did you know that this student is enrolled in you? If they didn't know, then we need to add the student to that to the enrolled students list. Okay. It won't work because I can't get the foreign key to work. But the relationship between the two would be the same, right? We find both objects. First, we find the section. We find the student. We can either go both ways. We could say section.enroll student, and we give it to students, and then we tell the repository to save the section, or we could say student.enroll section. The section, and then say, student repository dot save student. Either way, right, it'll do exactly the same thing. But because we could have chosen either way, right? We have to provide both functions, right, to allow folks to use one way of direction or the other. Right. This is testing the other way around. The enrollments, we can Two use cases, very common, right? If I'm the registrars, I would typically look for things from the sections point of view. I want to list all the sections, right? And then maybe from a course I navigate to the sections. I choose a section and I see all the students that are enrolled in that section. If I'm from the point of view of the registrars, from the point of view of the student, I want to see all the courses that I'm enrolled in, and then what sections am I enrolled in that particular course. So yeah, we have to provide both use cases, right, so that you can navigate from both ends. We'll come back a little later when we do a NoSQL, and so that's going to be an additional complication, since in NoSQL we don't have relationships, we don't have join tables, we don't have foreign keys, we don't have any of that. Although you could model them the same, but they're not built for that. Right? That's not their main focus. Relationships is not their focus, right? If you're going to use relationships, use a relational database. So in a relational database, notice that the fact that the student and the sections are associated somehow, that information does not live with the student and it does not live with the section. Instead, there is an enrollment table that has that information. Okay? But if we were using a non-relational database, the most common way to store this information is either from the point of view of the student or from the point of view of the section. Meaning when you query the student, ideally the object that would come back from the database would already have all the sections that are associated to that student, right, as one query to the database. Ideally, it would be stored that way. Okay? So that would allow you to implement the use case of the student being able to see the sections that they're enrolled in. But if I query from the section and I want to know the students that are enrolled in that section, ideally it would be also stored that way, right? That I have a section and then all the students enroll in that section. But notice that introduces redundancy, right? Because I have the same information stored in two different places, right? The student knows about the sections and the section knows about the students. Ideally, that would be stored only in one place, right? So typically, depending on the use case, you would encode it differently, right? If the use case is that typically it is the student who sees their sections, but not that the registrar sees the students in a section, then typically you would store all the information on the student side, and you store all the sections in the students from the student's point of view. Or if the use case is that that the registrar sees all the sections and whatnot, then you would store all the students in the sections, right? So again, it depends on the use case. The use case drives your modeling, right? It is the requirements, right? The requirements from what you're being asked to do is what drives what you're going to implement, right? And it would typically use views or things like that will eliminate all the redundancy. Yes.
So what if both sides need to know each other?
Right. Then you would need a mapping. You would have a mapping.
We decide to choose the relational database instead of the NoSQL.
Right, exactly. If you have lots and lots of relationships, right, and you either choose a relational database, right, or you're going to have to resolve that relationship either at the database level or at the application, right, where you're going to have to do additional fetches, right, to retrieve iterate something on the application level and go fetch all the ones that are. And we'll see that it's fairly annoying, but there are libraries that automate all this joining, right? Because there's no join in a non-relational database. Nevertheless, it's a very useful feature. Right. Okay.